So the topic is sensible heat, and we will be aware about sensible heat from a curve or diagram, and what happens when we melt a ice to melt a ice to water and water to vapor, vapor. First ice at 0 degree Celsius, then it will convert ice at it may be at 4 degree Celsius, it will be converted to 0 degree Celsius, then water at 0 degree Celsius, then again the temperature rises to water at 100 degree Celsius, and then the vapor will be at 100 degree Celsius. Water at 100 degree Celsius, then our vapor will be 100 degree Celsius. Then what happens? First, from this is the temperature enthalpy curve, specific enthalpy curve. This is specific enthalpy. Then what happens when we heat ice at 4 degree Celsius to make it steam? First the temperature rises, then from 0 to 0 it will be constant temperature. Again temperature rises from 0 to 100 degree Celsius, then again 100 degree Celsius, the 100 degree Celsius to 100 degree Celsius, then it will be at constant temperature. Then what is sensible heat? The heat which cause the state to change. The heat which cause the state to change is called our sensible heat. And these are our sensible heat. From here to here it is our sensible heat from heat, and from here to here is our sensible heat. Then what is our 1 2 then what is our 2 to 3? 2 to 3 is our latent heat. What is latent heat? Latent heat is the heat at which the temperature of the state does not change, but the phase change occurs from one phase to another. It is our latent heat of here it is latent heat of the substance, and this is our sensible heat of the ice. At here it starts melting, and it melts at 0 degree Celsius. It be 0 degree Celsius of water, then it again steam, and again temperature rises, and so on. This much about the sensible heat. Stay tuned, we'll be back to you soon. Thank you. Hello friend, this time we are going to learn about entropy. We know that entropy is the degree of randomness of molecules. Then entropy, we are going to discuss about entropy is a point function. You may know entropy is point function, but have you ever tried to solve it or prove it? Not? If not, I will solve it. It is one of the important questions, and it is also important in regular. We have to know this. Any person walking on the street can ask entropy is a point function. How? Or any teacher and professor may ask this question. So you must know this answer. We draw a curve. We give this point as 1 initial point, and final point 2 as 2, and this path we take L, this path we take M, and this path we take N. To prove that is point function, it must satisfy that it only satisfies for, or it's only formulated for initial and final point, and it doesn't have a relation with the path, that is L path, M path and N path, or the area associated with the paths. So how to prove it? We know, and I hope you have read Clausian statement, Clausian's rule or statement. We say statement dq by dt, dq by t is equal to 0. You know this. Then and this is resultant, this is resultant, or we can write sigma of r dq by dt is equal to 0. For path we can write, for this path 1 L 2 M 1 L 2 M 1. What we can write, we can use this formula. This is 1 L 2 dq, sigma from 1 to 2 dq, or sorry, is differential of dq by t is equal to 0. So differential of, inexact differential of this, the path is L dq by t is equal to 0, that is, or from 1 to 2, and this also this, and another is this is for 1 to 2 with path L, and from this is the resultant. So 1 to 2 with L and 2 to 1, again it comes back from path M. So we have to do is this plus differential of 2 to 1 with M dq by t is equal to 0. Also for path we take this next path 1 M 2 N 1 M 2 N. If you haven't understood what I have written, you can recall. I had helped with renouncing it. This is differential sign, and this is differential sign, this nothing, and these all are same. And from 1 M to N 1 M to N, this path, on this path what we can write, this plus this dq by t from 2 to 1 or 1 to 2 with path N, and of 2 to 1 M, it is M, and from 2 to M it is M, and from 2 to 1 with path N dq by t is equal to 0. Now what we do? Now we subtract this. This is 1, this is 2. 1 minus 2. What we get? We get here 1 to M dq by t, 1 to 2 M dq by t, 1 to 2. So what we get here? 5 1 to 2. This is for path Q, plus 2 to 1 for path M dq by t, or a minus of 1 to 2. When this M it is, so it becomes it is 1 to 2 of M dq by t plus 2 to 1, this is minus path N dq by t is equal to 0. Now what we have here, this L path, M path and M path. This is from path 1 to 2 and this is from path 2 to 1. That means 1 to 2 and 2 to 1 covers the same area. The area under the curve is same, so it cancel each other. When this and this cancel each other, then this is our del S, that is change in entropy, that is for L path, and is equal to when this goes next side it becomes del S n. Hence entropy does not depend on the area or path FOLLOW forward, hence point function. I hope you have clearly understood why entropy is a point function. Thanks, this much for now. Stay tuned.